Okay, thanks to all who attend. We have a session with two speakers this afternoon and regarding two quite exciting areas and discoveries. So, in order to save time, I will give the floor immediately to Jean-Jacques. Tu arrives à garder ton truc.
Good afternoon. May I have the first slide? Yeah. So I would like to entertain you with the recent advance on the question of origin of Homo sapiens, and it touched many topics that I won't have really time to develop. Just to remind you what has been said several times already since the beginning of the meeting, moving back in time, we have a variety of forms of hominins, and there is much debate around among paleontologists to decide whether they represent biological species or not. Most likely, they never really were separated by complete reproductive isolation. But the fact is that this variety of groups disappeared about, I would say, 40,000 years ago, something like that. And today there is only one species of humans that replaced all the others, even if in some cases there is a partial absorption. And there are many questions about why this happened, because in I would say, the scale of geological time, that's quite a unique situation, in fact. And not only these species replaced others, but also colonized all sorts of environments where hominins never lived before. And this was made possible, of course, by technical improvements. It's not by biological adaptation that humans are able to live beyond the Arctic Circle. Importantly, and I think we should always keep this in mind, it was made possible by a high complexity of social interactions. And when I say social interaction, I don't mean only interactions between kin individuals inside families or little groups, but also the capability that humans have to build up extended networks and coalitions with people they don't know. So since in fact, even before Darwin, there was already discussions about why, what is the origin of the different groups of hominins. And for a long time, in the 20th century, there was a so-called multi-regional model that has been prevalent, with the notion that so-called modern humans emerged in different parts of Earth from different origins. And in the 80s of the past century is a out of Africa model that became prevalent. And this dominant model has been gradually elaborated, and mostly because of paleontological discoveries first. So there was a clear evidence that we have in Africa forms that are closer to extant humans long before anywhere else on the planet. And the focus was mostly put on sub-Saharan Africa, especially East Africa, also South Africa sometime, with the idea that there was a sort of Garden of Eden where humans would have emerged in a sort of Adamic way very quickly. The argument was also a genetic argument, and this is a tree. This complex tree shows you different haplotypes of the mitochondrial DNA, a very simple form of DNA that is transmitted only or mostly by females. And we can reconstruct a tree like that with all the populations of Earth. What you see on the left of this picture, what is highlighted in green, are all African populations. And so if you turn this tree upside down, you have actually a tree that is rooted in Africa and with a big branch going over the wall of the garden into the rest of the world. And this kind of picture has been provided by many studies in genetics. This is mitochondrial DNA. The Y chromosome gave the same results. Studies on nuclear DNA as well. On top of that came the notion of the emergence of what has been unfortunately called cultural modernity. I think it's a very debatable concept, but to put it simply, the idea was that in some parts of Africa, again, first East and South Africa, mostly South Africa, there was the emergence of more complex technologies and the spread of non-utilitarian objects like these beads that you see on the right of this picture, and that all this together pointed out the notion that, again, there was a sort of Garden of Eden in this part of Africa where so-called modern humans emerge. I want to take you very far from East and South Africa. I think it's difficult to go further away from these regions when you're in Africa. I want to take you to Northwest Africa in Morocco. And we are here on a hill near a village called Tlalet Irud, and this hill is called Jebel Irud, the mountain of Irud. The view is taken to the southeast. What you see there at the horizon is the high Atlas mountains with snow at the top. And beyond these mountains, the Sahara starts very soon. So we are between Marrakesh and Safi, not very far from the Atlantic coast. And this place is very well known by paleoanthropologists because in the early 60s, there was already the accidental discovery of a skull of one hominin in a barite mine. The miners digging into this hill cut a karst that was full of sediments. These sediments collapsed in the gallery of the mine, and there was bones and stone artifacts, and there was this skull. The letter you see on the left, unfortunately you cannot see the writing, but it was sent to me by the early 90s by the medical doctor who was in charge of the miners, Dr. Boudard, and he sent me this letter when he was already retired in Bruxelles, and he describes this discovery. The skull of Irud 1 was soon interpreted by a paleontologist called Emile Enouchi as a local Neanderthal. I think we must be forgiving for this interpretation. In this time, anything with a large head, a big brain, and big brow ridges was recognized as a Neanderthal. And so there was this idea that maybe in Africa, there was also in North Africa at least some kind of Neanderthals. And plus the lithics coming from the site looked a bit like Middle Paleolithic artifacts that were found in Europe. There was attempts to date the site that I must say were quite unsuccessful. For a long time, the site was considered to be rather recent, which of course was a problem to fit into the general picture of hominin evolution, this specimen. To put it simply, it looked more primitive than the East African skulls that I showed you just before that were between 200 and 150,000. And if this stuff was more recent, it was difficult to put it into the, I would say, to set him in the mainstream leading to extant humans. So in 2004, soon after I took the position of director at the Max Planck Society, one of my first projects was to return to Jebel Irud and to see if there was a possibility to re-excavate the site. I have been interested in this material for many years, actually, since I was a student, and Professor Pifto gave me a little mandible coming from the site to study, and it was one of my first publications in my career. Well, I won't tell you when, but it was a long time ago. And the idea of returning to Irud was to find a way to date the site more precisely. And in particular, we wanted to use a method called thermoluminescence. And to implement this method, you need two things. You need to have a good dosimetry of the site, which means you need to measure the local radioactivity of the sediments in a precise way, something that previous studies did not manage, and also to have burn flints. Why burn flints? Because these burn flints, when they're exposed to temperature above something like 400 Celsius, they let energy go in form of light, and then when they are buried again, they reaccumulate energy because of this radioactive ambience. And the measurement of this rate of energy is a way of dating the sediments, or at least the time of the last heating of the flints. So if you look well at this stratigraphy, you see that we have been able to locate in situ sediments, to excavate a stratigraphy of about 3 meters. The red spot that you see are new hominins that has been found during our excavation, and the yellow spots are burned flints, heated flints, that we have been using for the dating of the site. You see already on this profile that most of the hominins come from one layer that is called layer 7. There are some others above, but mostly from this rather thin layer at the bottom of the site. And it's quite possible that this accumulation of hominins is one event. We have the remains of we have the remains of at least 5 individuals, and these 5 individuals are represented by 27 pieces of hominins. Of course, it's not as nice as what we saw yesterday in the Naledi cave, but I would say for this period of time in Africa, it's remarkable. And we have probably the best set of fossils for this time period in Africa. So in addition of the material that has been discovered by previous excavations in the site, we had another skull, another face, very well-preserved adult mandibles, and a number of postcranial elements. Importantly, implementing this thermoluminescence method, it has been possible to provide an accurate age for the site of about 300,000 years before present, and to confirm this age with another method, which is ESR, that has been previously implemented in the site, but without a good dosimetry. So the results of our excavation, the dating, the new hominins, allowed us to publish 2 papers in Nature in 2017, and to have the privilege to be on the front page of the journal. These works received a lot of attention, with more than 3,000 recensions in international press, not only because the age of the site and the hominin, but also because of the conclusion we could withdraw from their study. So if we look at the morphology of these remains, what we see is that in terms of morphology, these hominins from Jebel Irhoud, about 300,000 years old, have a facial morphology that is basically the same that your facial morphology, even if the size is bigger. Of course, robusticity is large, but in terms of shape, is very similar. On the diagram you have on the left, you have a morphometric analysis showing with all these pink stars, different options for the reconstructions of Irhoud hominins, and they all fall within a blue cloud representing extant humans, or upper Paleolithic Homo sapiens. What you have on the top is the distribution in pink of Neanderthals, and in yellow of the face of hominins that have been mentioned earlier today, called Homo heidelbergensis, and that have been long considered to be a possible common ancestor of Neanderthals and extant humans, and I'll come back to this issue. But you see already that from the point of view of the facial morphology, Homo heidelbergensis is quite similar to Neanderthals in some respect, while extant humans have retained a number of primitive features that you already find in Homo erectus. And the conclusion of that is that both Neanderthals and heidelbergensis are in fact derived when compared to this primitive morphology. We find also shared derived conditions on the mandibles, on the dentition. Of course, this mandible is not the mandible of an extant human. It does not have a pronounced chin, but you could go into the details of the teeth, for example, and find many features which are reminiscent from what you find in more recent Homo sapiens. The interesting thing is that beside these shared derived conditions or retention or primitive condition, we have something very different when we look at the endocast and when we look at the morphology of the brain inside. Again, you have on the left side, you have a blue cloud showing extant humans, a green triangle showing erectus, a red polygon showing Neanderthals and Homo heidelbergensis, and the Earwood specimens come. There is a small animation that disappeared with the conversion from Keynote to PowerPoint. So the Earwood specimen, they are between the green triangle and the red polygon, and they order with other specimens, including the East African specimen that I showed you, in a sort of gradual order, entering the variation of recent Homo sapiens. And so the conclusion of that is that, first of all, Earwood retained a rather primitive condition, an elongated shape of the endocast, and also that, again, we have conditions in heidelbergensis and in Neanderthals which are quite different, and heidelbergensis does not fall in a situation intermediate between what we have in erectus and what we have in Homo sapiens. So again, for these features, it is somehow too derived to be a reasonable ancestor for, at least for Homo sapiens. In association with the Earwood hominins, we have a Middle Stone Age, an early Middle Stone Age that is known in other parts of Africa, East Africa, South Africa, and to date is the oldest MSA. As a working hypothesis, we propose that the spread of this form of MSA is related to the spread of archaic forms of our species. I'm not saying that the cradle of Homo sapiens moved from East Africa to Northwest Africa. I'm saying that at this point we don't have enough documents to really choose a place of origin. But it looks like if you move back, let's say 250,000 years ago, we probably have these hominins a little bit everywhere in Africa, even if the situation in South Africa with the presence of Naledi raised a number of questions regarding the coexistence of these hominins or the possibility that one came after the other, Naledi first, Homo sapiens after. In terms of fossil hominins, we have few hominins in Africa, especially if you consider the size of the continent, documenting this phase of evolution of our species. There are two specimens, basically, that are somehow reminiscent of Earwood. One comes from Kenya, Another one comes from South Africa. Both of them are not well dated, to say the least. And so I would say that's something that requires more research, more development to really reconstruct, I would say, the chronology, the timing of this story. The interesting thing about the Middle Stone Age is that it's within this Middle Stone Age that we start finding this new behavior that I mentioned in the beginning of my talk that has been labeled cultural modernity. And it includes some fancy artifacts, especially points. But more interestingly, we find now in several parts of Africa this non-utilitarian object, and especially these pierce shells, which are made from the shells of one specific genus of gasteropods, which is the genus Nassarius. And this is really something that I would say blows my mind, because there are many other gasteropods out there, and the reason why humans choose this one and use them not only in South Africa, but in very distant parts of Africa, like, for example, North Africa, or East Africa, or the Levant, outside of Africa, is really something extremely puzzling, because it shows that a very specific behavior was able to spread at a continental scale. And that, of course, implies some kind of connection between all this population that people, Africa, say between 100,000 and 50,000 years ago. And the other thing I would like to add is, whatever some of my colleagues who are, I would say, Neanderthal supporters would claim, there is nothing like that in the Neanderthal world at this time. There is not the systematic behavior of using a specific objects like these specific gasteropods in a, would say, symbolic way at a continental scale, and always the same way. The discovery of Hirud raised a number of issues and questions, and in relation with this notion of modernity, I would like to highlight the question of brain shape, brain structure, and underline the fact that, in my view, we should avoid to use the term modern humans to define this lineage, for the simple reason that if you look at the brain morphology of these hominins, it's different from the brain morphology of more recent Homo sapiens. And if you look on the left, the morphometric analysis of endocasts of different hominins, what you see is that going from the green triangle of erectors to the red cloud of Neanderthals, along PC1 you have mostly an enlargement of the brain, keeping more or less the same structure. With the blue triangles and polygons, what you have is different stages within Homo sapiens, where you see a divergence in a completely different direction. And there are two things to notice. One is that it's a gradual phenomenon. So it's very difficult to set I would say, a boundary somewhere, a threshold in this evolution. So there is no real limit to what we call modern humans from an anatomical point of view. The second thing is that if we look at what's going on along this evolution, we have a change in the organization of the brain shape with the development of parietal bossing, and in a very spectacular way, the enlargement of the cerebellum in our species, which is a very specific feature. Cerebellum has been a bit, I would say, neglected for a long time. The cerebellum was considered to be mostly involved in motor coordination, that's what you use when you do bicycle. It's also what you use when you speak. And the cerebellum of a human today has about half of the neurons of the whole brain in humans. And the recent works not older than a couple of weeks, there is a paper published in Science, showed that cerebellum is involved in rather complex tasks, including the rewarding system of the brain, and also it has been proven from an experimental perspective that it's involved in social interaction. So I'm not saying that something, I would say, special happened to our brain that make us social. On the contrary, I think something was developing among these groups of hominins that created the pressure of selection that led our brain to evolve into this direction. And if you go back to the picture on the left, what you see is that it's about between 100,000 and 50,000 years ago that we start finding individuals entering the present-day variation of this brain structure. Again, I don't think anything special happened at this time. It's a gradual evolution, but it questions, again, the notion of what we want to call modern humans. So I think we have to revisit the phylogeny of hominins that we have. This is quite different from the kind of tree I would have shown 10 years ago. Since the beginning of the week, already we have 2 publications that would oblige me to modify this tree. On the left side, we have, I'm sorry, the conversion from Keynote to PowerPoint is not great. Denisovans on the left and Neanderthals probably have a structure, a phylogenic structure more complex than what is represented here. The important thing is mostly that I think Heidelbergensis is already connected to these groups much more than it is with Homo sapiens origin, which raise an interesting possibility is the presence in Africa, not just in Eurasia, but in Africa, with Bodo and Kabwe, of an hominin, an archaic hominin that would have evolved beside the ancestors of Homo sapiens, maybe in some regions of Africa, not others, and which is connected somehow with Eurasian forms. Might be of Eurasian origin. Since we published our paper, there are a number of studies that has been elaborating on our results. A re-examination of the coalescence time of the present-day African population, pushing back the coalescence beyond 300,000, so we are very happy with that. And also we saw the emergence of a new sort of concept of Homo sapiens evolution and emergence of so-called, unfortunately, modern humans, which I would say it's a sort of multi-regionalism at the scale of Africa, with population would have evolved separately, especially during arid phases like MIS 2 or 6, when there was an extension of the deserts, a regression of the tropical evergreen forest, so separation of population with the development of mutations and innovation separately in all these groups. And on the contrary, during episodes that where there is more moisture, like green Sahara episodes, a connection between all these groups that would organize, that would allow gene flow and the sharing of some of this technical or behavioral innovation. What you have here on the left bottom is a map of Sahara during one of these green Sahara episodes. You see that you have rivers, you have lakes, some of them the size of Germany, so we're not talking about ponds, and a lot of archaeological sites. And this is a huge area. Just to give you an idea, I superimposed the map of America, United States of America. So all this area is covered with archaeological sites for some of the critical periods we are talking about. And so this would be periods where there would be more connections between all these African populations, and maybe the combinations of all sorts of features that we consider today being part of the definition of so-called modern humans. Two last comments about these changes, environmental changes and changes in distribution. When we have green Sahara episodes, these green Sahara episodes also occur in the Arabian Peninsula. And there are now a lot of studies showing that there are probably much older exchanges between Africa and the Arabian Peninsula that we thought before. These are Nubian cores that has been found not only in Egypt or Sudan, but also in the Arabian Peninsula. And it's very tempting to think that Homo sapiens forms of this time period not just dispersed passively in the Sahara, but also into the Arabian Peninsula. Nobody told them that this was out of Africa. You know, these guys had there is no panel saying you're leaving Africa, you're going to Eurasia now. And so I think we're still waiting for a physical evidence of this Homo sapiens out of Africa, but it's very likely that in the Middle East, in the Near East, there is a presence of Homo sapiens much earlier than we thought. And Israel Hershkovitz in a moment is going to show you the evidence from Israel, and you'll see that the occurrence of Homo sapiens of African origin in this part of the world is quite old, in fact. Interestingly, we have now genetic data, paleogenetic data, suggesting contacts between Neanderthals and population of African origins much older than, say, the usual time we have in mind for the replacement of one group by another. This is a picture taken from a paper, recent paper by Post and collaborators, showing the discrepancy that we have between the tree provided by nuclear DNA and mitochondrial DNA in all these hominins in this time period. And the way to interpret this discrepancy is by accepting the notion that there was likely an introgression of mitochondrial DNA of African origin into the Neanderthal genome, maybe as early as 300,000 years ago or something like that, which is the time of the Irud people. And by the way, a time where soon after MIS 9, where we had a Green Sahara episode, and all these groups were probably put into contacts. This kind of situation, this kind of introgression is something we know very well in the animal world. This is just one example. Polar bears and grizzly bears during the Pleistocene exchange mitochondrial DNA in several events, a little bit like Neanderthals, modern humans, and Denisovans. And by the way, if you consider the time of divergence and the difference in phenotype, there is about as many reasons to make polar bears and grizzly bears two different species than to make Neanderthals and extant humans two different species as well. Just to finish, I would just like to emphasize that there is no rapid emergence of our species in a sub-Saharan cradle. It's a much more complicated story. It's a gradual phenomenon, is not a sort of Adamic moment where we have suddenly our species emerging. The term of modern humans, I think, is understood by some as in a cladistic sense, and another in a gradualistic, gradic sense. Homo heidelbergensis or rhodesiensis is very unlikely to be the ancestral form of extant humans. We think it's a side branch. And this raised the possibility that we have two, maybe three different paleospecies chronologically overlapping in the late middle Pleistocene of Africa, which is something very puzzling. Thank you for your attention.